Imagine the bridge of a Federation starship. The ship is cruising through deep space at warp 9. The engines are stable, the crew is calm, the computer has plotted the route. Then suddenly, the tactical officer looks up. "Captain, another starship is directly ahead." There isn't a warning. There isn't enough time to turn. Both vessels are already traveling at warp. Two massive starships are about to occupy the same piece of space. So what happens next? Would they simply explode? Would their shields protect them? Would their warp fields interact? Or could the collision actually tear open space-time itself? To understand the answer, we first need to understand what warp speed actually means. The biggest mistake is imagining a starship at warp 9 as a normal object moving through space at some absurd velocity. That's not how warp propulsion is generally portrayed in Star Trek. A warp drive generates a field around the ship that manipulates space-time. The vessel effectively travels within a region of distorted space. This is why comparing warp 9 directly to something like kilometers per second doesn't completely work. And it creates a fascinating problem. If two starships are both traveling at warp, they're not simply two cars speeding toward each other. They're two enormous warp fields moving through space-time. And when those fields meet, things could become very ugly. Under normal circumstances, a collision should be almost impossible. Starships have long-range sensors. Their computers constantly calculate trajectories. They know where other vessels are. They know where planets and other major objects are. And their navigational computers can adjust the ship's course. But imagine something goes wrong. Two starships are traveling toward the same location. Perhaps their sensors are damaged. Perhaps one ship suddenly emerges from warp. Perhaps a cloaked vessel becomes visible only moments before impact. Now the crews have a serious problem. At high warp, there may be almost no time to react. This sounds easy. Just turn the ship. But at extreme warp, changing direction isn't like steering a car. The ship's warp field itself has to change. The navigation computer has to calculate a new trajectory. The propulsion system has to modify the field. And the ship's structural systems have to survive the maneuver. This is why starships don't casually make sharp turns at maximum warp. A sudden course correction could be dangerous, even without another starship in front of them. Now imagine doing it when the other vessel is only seconds away. Suppose neither ship manages to escape. The two vessels collide. The first thing we'd expect is a catastrophic disruption of their shields. Starship shields are designed to absorb enormous amounts of energy. But shields aren't simply invisible walls. They're part of a sophisticated defensive system that interacts with incoming energy and matter. A direct collision with another starship would be an extraordinary event. The shields could absorb some of the initial impact, but eventually the energy would reach the hull, and then the real destruction begins. A Federation starship is enormous. A Galaxy-class vessel is over 600 meters long. Now imagine another enormous spacecraft striking it while both are traveling under warp propulsion. The impact wouldn't necessarily look like two metal objects crashing into each other. It could be much more violent. Structural integrity fields would be pushed beyond their normal limits. Hull sections could shear apart, decks could collapse, power conduits could rupture, warp nacelles could be destroyed, and critical systems could fail almost instantly. The crew would have only seconds to respond. A starship collision becomes much more dangerous when you remember what's inside these ships. A warp core is an incredibly powerful energy system. Federation starships commonly use matter-antimatter reactions to generate enormous amounts of energy. Now imagine two starships colliding. Their hulls are damaged, their engineering sections are destroyed, their antimatter containment systems are compromised. Suddenly, the collision isn't just a structural disaster. It could become an enormous energy release event. And if both warp cores are damaged badly enough, the result could be catastrophic for everything nearby. This is where things become much more mysterious. Now, if two starships collide while both are generating warp fields, what happens when those fields interact? Star Trek doesn't provide one universal answer, but we can reason from the way warp technology is portrayed. Warp fields aren't passive bubbles. They're active distortions of spacetime generated by the starship's propulsion system. If two massive warp fields suddenly interact, the interaction could destabilize both propulsion systems. The result might be a sudden loss of warp, or something far worse, a warp core breach, a catastrophic field collapse, or potentially an unusual subspace event. And this is one reason a collision at warp is fundamentally different from two ships crashing at impulse speed. Here's another common misconception. Suppose one ship is traveling at warp 9, another is traveling toward it at warp 9. Does that mean they're colliding at warp 18? No. Warp factors aren't ordinary velocity measurements. The relationship between warp factor and apparent velocity is non-linear, and different eras of Star Trek even use different warp scales. So you can't simply add the two warp numbers together, but that doesn't make the collision safe. The relative motion between the two ships could still be enormous. Possibly, but only to a point. Starship shields are incredibly powerful. We've seen them survive weapons fire, explosions, radiation, and enormous physical forces. But shields aren't designed to make a starship completely immune to momentum. If two ships physically occupy the same location, something has to happen. The shields might absorb some of the energy. They might prevent the hulls from immediately touching. They might even cause one ship to be pushed away. But if the relative energy is high enough, the shields could collapse. And once that happens, the hull takes the impact. This might actually be the best survival strategy. If the crew detects the other starship early enough, they could immediately drop out of warp. Now the ship is no longer traveling through a warp field. It has much more conventional control over its movement. The crew could attempt to maneuver away, but there's a catch. If the other ship remains at warp, the situation becomes extremely complicated. The relative motion between the two vessels could still be enormous. So the safest solution is for both ships to leave warp before reaching the same region of space. Probably not, simply because two starships collided. This is important. A black hole isn't created just because something releases a gigantic amount of energy. You need an enormous concentration of mass energy compressed into a sufficiently small region. A starship collision would be devastating, but a Federation starship simply doesn't contain enough mass to collapse into a normal black hole under ordinary circumstances. However, Star Trek frequently includes exotic phenomena involving subspace, singularities, and artificial gravitational effects. So if the collision occurred under extremely unusual conditions, near a wormhole, a powerful gravitational anomaly, or some exotic subspace phenomenon, the result could be far stranger. But that's speculation rather than established canon. The most terrifying scenario isn't necessarily the explosion. It's the possibility that the warp fields interfere with each other before the ships physically collide. Imagine the two vessels approaching. Their warp fields begin interacting. Sensors become unreliable. Navigation calculations start changing. The warp fields destabilize. The ships suddenly drop out of warp. One vessel loses propulsion, the other suffers a warp core emergency, and now both damaged ships are stranded in deep space. The collision itself might last less than a second, but its consequences could continue for hours or days. Not necessarily. Star Trek starships are designed with extraordinary redundancy. A collision could destroy entire sections of a vessel while leaving other sections relatively intact. Emergency force fields could seal damaged compartments. Internal doors could isolate decompressed areas. Transporters could evacuate injured crew. Escape pods and shuttlecraft could provide additional evacuation options. And the ship's computer could automatically shut down damaged systems to prevent secondary disasters. So, a collision doesn't automatically mean everyone dies, but a direct collision between two starships at extreme warp would almost certainly rank among the worst accidents imaginable in Starfleet. Because Starfleet has an enormous technological advantage: prediction. A starship doesn't wait until an object is directly ahead. Sensors detect hazards. Computers calculate trajectories. Navigation systems plot safe warp routes. And starships can reduce speed or leave warp when conditions become dangerous. That's why two starships accidentally colliding at warp should be extraordinarily rare. But that's not impossible, because the universe contains something computers can't completely predict: the unexpected. A ship can suddenly emerge from warp. A wormhole can appear. A cloaked vessel can cross the flight path. A spatial anomaly can distort navigation. And in those situations, even the most advanced starship may have only seconds to react. So what happens if two starships collide at warp? The most likely answer: catastrophic damage to both vessels. Their shields could absorb some of the initial energy. Their structural integrity fields could delay total destruction. Their warp systems could destabilize. Their hulls could be torn apart, and damaged warp cores could turn the collision into an even greater disaster. But the most fascinating part is that Star Trek doesn't give us a simple equation for what happens when two warp fields occupy the same space. And that's what makes it so mysterious. Because at warp, you're not simply asking, what happens when two objects hit each other? You're asking something much stranger. What happens when two machines are simultaneously bending space-time in opposite directions and then try to occupy the same piece of reality? And if that ever happened at maximum warp, the collision might be the least interesting thing that follows. And that is all for today. Thanks for watching and catch you in the next one. Take care.